Hello friends, in this lecture I will be explaining you the use of log tables. Log tables are used to solve questions involving big numbers or very small numbers. My name is Yogeshwar Singh and let's start with the chapter of log tables. Log tables are of two types. First one is logarithmic table, which we use to calculate the exponent corresponding to that number to a particular base. And the second is called anti-logarithmic table, which is used to calculate the number from the exponent to that particular base. That is, this will give you the answer, because the exponent is not our answer is the actual number on which we are performing the operations. So using the anti-log tables we calculate the actual number corresponding to that exponent. Before using log tables you need to understand a few things. First is the base of log table. The log tables are designed on different bases. Normally we use log tables based on base 10 and these are called normal logarithmic tables. Another important base involved in logarithm is e. E is a sum of infinite series. Its value is approximated to 2.71828. The second is standard form of decimals. The standard form of decimals means if we are given a number 7436.43, so this decimal keeps varying depending on the size of the number. Sometimes you might get 0.0000546 etc. So to standardize this we always bring the number between 1 to 10. Here you see 7.43643 is the number between 1 to 10, and the decimal places which we shift we adjust it by multiplying a multiple of 10, that is 10 cube. If you multiply this 1000 into this number we get 7436.43. So basically these two numbers are same. This form is called the standard form or scientific form of the number. It is just a representation. We are not changing the number. Few things to remember. Note, if the base of log is not mentioned, then if the expression is log, if this expression log is written, then it's understood that the base is 10. You have to use with this expression base 10. This is also called normal logarithm. If the expression is ln, if you are seeing this ln expression in question, that is ln x, ln 2, ln 4, ln 5, it means the base is e. This is called natural logarithm. In all other cases the base is always mentioned with the expression. For example, log x to the base 2. Here the base of logarithm is 2. Understanding the process and terminology. Before we proceed with the use of log tables, you understand that if we write any number in scientific form or standard form, then m is equal to n into 10 to the power p. Here n, this number lies between 1 to 10. It can be equal to 1 but cannot be equal to 10, because if it is equal to 10 then we will increase this p by 1. P belongs to integers. Now taking log of this relation on both the sides, we get log of m is equal to log of n into 10 raised to the power p. By applying the properties of logarithm, we get log n plus log 10 to the power p. The exponent comes out, gets multiplied, and we get log n plus p log 10. As we all know that if log is written the base is 10, then log 10 to the base 10 is 1. Therefore, log m is equal to p plus log n. Here p is called the characteristic, which is always an integer, and log n is called the mantissa, which is always a positive fraction. That is, this log n lies between 0 to 1. It can be equal to 0 but never equal to 1. Let's understand why this happens. Since we have made sure that n lies between 1 to 10 when we are converting this number into standard form, If we apply log to the base 10 on both the sides of this inequality, since graph of log is an increasing function, if base is 10, I have already discussed that, then if we apply an increasing function on this inequality, the sign of inequality remains same, it will not change. And hence we can say that log of 1 to the base 10 should be less than or equal to log n to the base 10 should be less than log 10 to the base 10. The value of this log 1 to the base anything is 0, log a to the base a 1. Therefore, log n to the base 10 will lie between 0 and 1. You have to remember this thing very thoroughly, because after getting the value from the log table, you need to put this decimal. Let's see how to use log tables. From now onwards, we'll be learning how to use log tables. So you have to have log tables standby. You can download these log tables from internet, or it is also available in the video link given in the description. We'll be using it to solve the questions. See, log tables look like this. In general, the log table which we use to the base 10 is in two parts. One part starts from 10, goes till 54, then 55 to 99, or this may be distributed somewhere else, but main thing is that you should be having the numbers from 10 to 99 in the first column. Second is this row. In this row you will see two sections. One section is 0 to 9. This is the value of main logarithm, and this is mean difference 1 to 9. We'll see when to use which part, but you have to use this column, this row and this part to calculate the value of log of any number. Now we go see how anti-log tables look like. The anti-log tables are almost similar in appearance, but the only difference is here you see numbers starting from 0.00 instead of 10. It starts from 0.00 and goes to 0.99. The first row's construction is same, 0 to 9, and then the mean difference. We have to use these things and calculate the logarithm. Construction of log tables, you have to find your number by combining this column, this row. So this column tells you that which row to be used. You'll find one of the numbers over here, and then you will see which row to be used. After deciding which row to be used, you decide which column to be used. This will decide which column to be used. After finding the row to be used and the column to be used, we get a value. We note down this value, then we proceed forward in the same row, and then we get the mean difference. The corresponding mean difference we note it down. So let's use the log tables to find the value of any number. For example, what number which we took in the beginning, that is log of 7436.43. If we have to find out the log of this number, what we do, first we convert this number into standard form. We write it log 10 7.43643 into 10 cube. Then applying the properties of logarithm, we get log 7.43643 plus log 10 cube. This 3 comes out, gets multiplied, and log 10 to the base 10 is 1. We get 3 plus log 7.43643. Here 3 is known to us. This is the characteristic which I was talking about. This is the characteristic of this logarithm, and this part is the mantissa. This number will always be an integer, and this number will lie between 0 to 1. Before we start, remember that log tables gives us approximate values. Okay? The numbers are very big, so a small difference in big numbers doesn't matter that much. These log tables reduces our calculations, but the drawback is it does not give you the exact value. Let's see how to find the log of 7.43643 to the base 10. We see, we consider this first 4 digits of the number. Remember, this is why there is a correction in logarithmic calculations, because we are ignoring this 4 3. We write down these first 4 digits 7436 and divide it into 3 parts. You have to always divide it like this. If the numbers are 2 digit, 3 digit or 1 digit, you make it 4 digit by adding zeros in the end. Like if you are getting 7.00000, then you write, or you get only 7, you write it down 7.000, then you write 7000. So here we'll divide it into 74, then 3 and then 6. Now this 74, you have to find it in the first column. This 74, when you find it, I have cut down the corresponding part of that log table, and see, 74 is written over here. We mark this row. This row is to be used. Only this row to be used. Nothing else is required in this log table for this question. Next is, we find this 3 in the first row. Then corresponding value we note down. We see in this row containing 74, the number in intersection of this row and column, we get 8710. You note it down. This is the main value of the logarithm. Then we look for the third number 6 into the mean difference. We have noted it down 8710 over here, and then in this 6, same row you proceed and find the number corresponding to 6. You add these two numbers 8710 plus 4, you will get this 8714. This 8714 is not the value of log 7.43643 to the base 10. This is the number associated with 7436 as per log table. To make it the value of this log, we need to place the decimal accordingly. And to place the decimal, we have to recall this theory which we discussed earlier, that since n lies between 1 to 10, its log value lies between 0 to 1. Therefore, log of 7.43643 to the base 10 must lie between 0 to 1. Therefore, we have to place the decimal in the beginning of the 4 digits, that is 0.8714 is the value of log 7.43643 to the base 10. Now, our actual number was 7436.43. For its value, log of 7436.43 to the base 10, we need to add the characteristic. This is the corresponding multiple of 10 to be multiplied to this number to get 7436.43. So after adding 3, we get 3.8714. This 3.8714 is the value of log 7436.43 to the base 10. Let's discuss one more example. I have discussed a big number that was not rather that big, but for the sake of understanding, that was quite big enough. Let's see a very small number. For example, we have to find the log of 0.00002456. We'll do exactly same thing, convert it into standard form, apply the properties of logarithm, and we'll get this minus 5 as characteristic. Here the characteristic is negative. And again, log of 2.456 will be a positive fraction lying between 0 to 1. From the tables, you can go to the tables, refer 2456, 24th, look for the 24 in first column, then the corresponding row, you look for 5 and then 6. You will get 3892 and the mean difference 11. You add these two, you get 3903. The value of log 0.00002456 is minus 5 plus 0.3903. Don't write it as minus 5.3903. This is wrong, because this number is entirely negative and this number is a positive fraction. So you have to add this thing to this minus 5. You will get minus 4.6097. Remember this while using the anti-log tables also, because this number after taking the log cannot be negative, it is a positive fraction. Okay, this is your answer. Points to remember: this minus 5 is negative, this is positive. Either you can add both of them and write minus 4.6097, or you can leave it like this, or you can write this kind of representation is also used, that is, you write, draw a bar above 5, meaning that only this part of the number is negative, minus 5 is negative and rest all is positive. Let's see. Remember, log of any number is integer plus a positive fraction. Integer plus a positive fraction. The integer is called the characteristic and positive fraction is called the mantissa. For general use, you need to remember the value of these two logs, log 2 and log 3. You can very well easily find it out from the log tables. That is, log 2 is 0.3010, that is 20 in 00, and log 3 is 0.4771, 30 in 00. You will get, remember these two values. If these two values are used in some of the questions, they don't give the log table. If some big numbers are involved or some unusual numbers are involved, then they provide the log tables. Otherwise, you are supposed to remember these two values. Okay, thank you very much. Next lecture is on use of anti-log tables. Please do subscribe to my channel YLC, that is your learning curve. Don't forget to press the bell icon. Please do suggest in suggestions box. Remember, as I always say, practice makes a man perfect. There is no substitute for hard work. Thank you for watching.